Hey everyone, here's the Spec Exam 1. I haven't heard anything about it, so we'll find out. Find the equation of the tangent to the curve. This is implicit differentiation. So you've got to say e to the negative 2y minus 2x e to the negative 2y dy dx plus 2y e to the x dy dx plus y squared e to the x equals 0. And then plug in the point 4, negative 2. So e to the power of 4 minus 8 e to the power of 4 dy dx minus 8 e to the 4 dy dx plus 4 e to the 4 equals 0. So what did I do? That's minus 4 e to the 4. So that'll be negative 12 e to the 4 dy dx equals negative 5 e to the 4 dy dx is equal to 5 on 12. And then you can use the point. So y plus 2 is equal to 5 on 12 x minus 4. Y is equal to 5 on 12 x minus 5 on 3 minus 6 on 3 is minus 11 on 3. Find the coordinates of the point of intersection of the two lines. So you can say 2 plus t is equal to 1 minus s. You can say 3 plus 2t is equal to 3 minus s. And you can say 1 minus t is equal to 2 plus s. So for the first two, I'll just change this. So that's t plus s equals negative 1. And 2t plus s is equal to 0. So if you subtract, you'll get negative t is negative t is equal to negative 1. T is equal to 1. And that makes s equal to negative 2. So when you plug in t as 1 into the first one, you'll get 2 plus 1, which is 3. 3 plus 2, which is 5. And 1 minus 1, which is 0. I don't know why that was 3 marks. Use integration to show that the displacement of the particle relative to O is given by that. So the displacement, so then we've got to integrate x of t is equal to the integral of t over t squared plus k to the power of a half dt. You can put a 2 here, put a 1/2 here, and then that just becomes 1/2 times the integral of u to the power of negative a half du, which is, if you add 1 to the power, it will be u to the power of a half, divide by 2 will cancel the half. So it will be square root of t squared plus k plus c. X of 0 is 0 because it starts at O. Therefore, 0 is equal to root k plus c. C is equal to negative root k. And then you can say that x of t is equal to root t squared plus k minus root k. That could have been 2 marks. Find the initial acceleration in terms of k. So what you'll notice is that the antiderivative of this is equal to that. So the derivative of that is equal to that. Sorry, that's just the, I'll just do it properly. That's just the derivative, the denominator. So u is equal to t, u dash is equal to 1, v is equal to t squared plus k to the power of a half. V dash is equal to 1/2 times, so that's going to give you -1, negative t over, what am I saying? 1/2 times 2t is t over the square root of t squared plus k. So what you can basically say is it's going to be root t squared plus k, a of t, root t squared plus k minus t squared over root t squared plus k, all over t squared plus k. A of 0 is equal to root k minus 0 over k, or 1 on root k, if you like. Another particle starts at O at the same time as the first particle and follows the same path. Its position is described by that. 3 seconds after leaving O, the second particle is 1 meter ahead. So S of 3 is equal to 3. That should mean that X of 3 is equal to 2. So you can plug in 3, no, that's not the, X of t is root 9 plus k minus root k should be equal to 2. And then what you can do, I would move the root k to the other side. And then if you square, you'll say 9 plus k is equal to 4 plus 4 root k plus k. These go. And you have 5 is equal to 4 root k. Root k is equal to 5 on 4. K is equal to 25 on 16. Using integration, show that E of t is equal to 1/2. So we need to say that E of t is equal to 3 over 2 ln 2 times the integral from 0 to 1 of t over t plus 1, t 2 minus t, dt. And then what you can do is you can do partial fractions. I'll just say t is equal to a times 2 minus t plus b t plus 1. If you say t is 2, you'll have 2 is equal to 3b. Therefore, b is equal to 3 over 2. If you say t is -1, you'll have -1 is equal to 3a. So a is equal to -1/3. And then what you can say is E of t is equal to 3 over 2 ln 2 times the integral from 0 to 1 of -1/3 over t plus 1, and then plus 3 over 2 over 2 minus t. And for that, what you can say is 3 over 2 ln 2. What do we have? So this one will be -1/3 ln t plus 1. And then this one will be, you need a negative on the top and a negative on the outside. So it'll be minus, and then the 3 over t, 2 can come out. So minus 3 over 2 ln absolute value of 2 minus t from 0 to 1. If you plug in 1, you'll get -1/3 ln of 2. And then minus, you have ln of 1, which is 0. And if you subtract, you'll say that will be 0. And you'll have plus, or minus ln of 2. So plus 3 over 2 ln of, oh, I made a mistake. I was wondering, these don't add up. So this one here is supposed to be 2/3. Meaning this is 2/3. Meaning this is 2/3. And this is 2/3. Okay. Ln of 2. And then you'll say that that's equal to 3 over 2 ln 2 times by 1/3 ln of 2. That and that go, which is 1/2. Okay. For random samples of 25 waiting times, it may be assumed that the sample means are approximately normal distributed. Find the probability that the average waiting time for a random sample of 25 patients is between 0.44 and 0.5. So the waiting time should be the same. And then the standard deviation would be, the standard deviation they said use as 0.3 divided by 5. So that will be 3 on 10 times by 1 on 5, which is 3 on 50. And we want to know the probability that x bar is between 0.5 or 1/2 and 0.44, which is 22 over 50. And you can simplify that further, but I'll just keep it because the standard deviation is over 50. So we can say that we'll convert these because they said use it. So z is equal to 22 over 50 minus the mean, which we'll say is 25 over 50, and then divided by the standard deviation, which is 3 over 50, which is negative 3 over 50 over 3 over 50, which is -1. And then z2 is equal to 1/2 minus 1/2, which is 0. Okay, so this is basically the probability that x bar, or z, sorry, is between 0 and -1. Now if you draw that out, you've got 0 is bang on in the middle, and -1 is here. Now we know that less than 1 is 0.84, so that means greater than 1 is 0.16, meaning this is 0.16. So you can write that out. You can say probability of z greater than, or you can say less than 1. Oh, well, we'll say greater than 1 is equal to 0.16. Therefore, probability that z is less than -1 is equal to 0.16. Therefore, this is equal to 1 minus 0.32, which is 0.6. No, we just want this. So, what's that? Less than 1 is 0.84, and less than -1, sorry. This whole thing is 0.84, and then minus 0.16. Yeah, so 0.84 minus, which is 0.68. Yeah. That? It shouldn't be. It's just one standard deviation away from the mean. Oh, again, I've done this. It should just be 0.34, which is half of the 0.68. So this is the 0.68. And what am I doing? I can just say 0.5 minus 0.16. What am I? That's 0.34. Okay. Show that for collision to occur when t equals 1, the value of c is -4. So for the collision to occur, the times are the same and the positions are the same. So Rp of 1 is equal to 1 plus A I minus J, and Rq of 1 is equal to B plus 2 I plus 2 plus 1 is 3 plus C J. Collision to occur when t is equal to 1. So basically, 3 plus c is equal to -1. C is equal to -1 minus 3, which is -4. When the particles collide, their velocities are at right angles to each other. Find the two possible values of A for collision to occur when t equals 1. So when t equals 1, as we said, I'm just going to copy and paste these. And also the velocities are at right angles to each other. So the dot product of the velocities are equal to 0. So R dot P of t is equal to, that's 3t squared plus 2at I, and then minus 0j, and then Rq dot of t is equal to b plus 2 I, and then plus 4t plus c plus 1. And we know that c is -4. So -4 plus 1 is -3. Okay, and then they're at right angles to each other, so these dot products are 0. So that means 3t squared plus 2at times b plus 2 and then plus 0 equals 0. Now we know b is b 0. Can b be 0? B, so either b is equal to -2 or 3t squared plus 2at equals 0, t, and then 3t plus 2a equals 0. Oh, it was at t equals 1. So I'll just plug in 1. So that would be 3 plus 2a and b plus 2. So what? That's just a 3 plus 2a equals 0. A equals negative 3 over 2. But there has to be another one. Find two possible values of a. B equals negative 2, but three t squared plus 2at, and then b plus 2 and 4t minus 3. If b is negative 2, what's a? When b equals negative 2, you've got that this is 0. So then a should be negative 1. I think I made a mistake, but I think that's fine. When the particles collide at t equals 1, the magnitudes of their acceleration are equal. Find the values of a and b for the collision to occur when t equals 1. When the particles collide at t equals 1, the magnitudes of their accelerations are equal. So the acceleration is, so I've got the derivatives. So these are the velocities. R double dot of t is equal to 6t plus 2a I, and then R double dot of p of t, or of q, is equal to, that one goes and you just have 4j. And when t is 1, R double dot of t of 1 is equal to 6 plus 2a. And that should equal to 4. So 2a should equal to negative 2. A is equal to negative 1, and then we can use that to find b, because we know that Rp of 1, so if a is negative 1, then b will be negative 2. Is that right? I think so. Okay. Find the volume of the solid of revolution formed on the area between the curve is rotated about the x-axis. So if it's rotated around the x-axis, it will be the integral from, it'll be pi times the integral from 1 to root 3 of arc tan x over 1 plus x squared dx. Yeah. And this here is, I just want to make sure, arctan looks like that. And yeah, from 1 to root 3, it's positive. Okay. So we can do a u sub. Let u be equal to arctan x du is equal to 1 over 1 plus x squared dx. And when x is equal to 1, u is equal to tan inverse of 1, which is pi on 4. And when x is equal to root 3, u is equal to tan inverse of root 3, which is pi on 3. So the volume is pi times the integral from pi on 4 to pi on 3 of, it's just u du, which is pi times u squared over 2 from pi on 4 to pi on 3. And then that works out to be pi times pi squared on 18 minus pi squared on 16. Oh, sorry, pi squared on 8. Oh, no. Pi squared on 9 and then divided by 2. Pi squared on 16 divided by 2. Pi squared on 32. That's annoying. What's the common denominator? I'm just going to multiply them. What did I do? 0, 2, 3. So what's that? 576. So that's pi times 32 pi squared minus 18 pi squared on 576, which is pi times 14 pi squared on 576, which is pi 7 pi squared on 288, which is 7 pi cubed on 288. That's annoying. Okay, hopefully I did that right. A pi to the power of b and c. Use mathematical induction to prove this. So, where the sum of that is equal to this. Okay, so first we can test the first case. You can say 2 squared equals 4, which equals to 1 over 6 times 1 times 2 plus 9 plus 13, which is 1 over 6 times 24, which is 4. So 1 holds. Then let's say that there exists So that exists. Therefore, the next value is equal to that plus k plus 1 or k plus 2 squared. Can that be factorized? I don't think so. 2, 1, 13 and 1. Okay, we can just say 1 over 6 times 2k cubed plus 9k. Oh, I haven't expanded it. So that's 1/3. I don't want to do that. Okay, whatever. 1/3 k cubed plus 3k squared over 2 plus 13 over 6k plus k squared plus 4k plus 4. You can say that's 1/3 k cubed plus 5k squared over 2 plus 24 plus 13. That's 37 over 6k plus 4. What do we want to end up with? Let's just write what we want to end up with. We want to end up with 1 over 6 k plus 1. And then 2k plus 1 squared plus 9k plus 1 plus 13. Okay. What we can probably do is take out 1/6. And then what we're left with is 2k cubed plus 15k squared. Is that right? 3, yeah. Plus 37k plus 24. Now, I'm assuming -1 is a factor because that's what we want to get. So if we plug in, that would be -2 plus 15 minus 37 plus 24. That is 39 minus 2, which is 37, minus 37, which is 0. So k plus 1 is a factor. So if we do long division, k plus 1 into 2k cubed plus 15k squared plus 37k plus 24, you'll have 2k squared, and then you'll have 2k cubed plus 2k squared. Subtract, you'll have 13k squared. And then you multiply, and you get, and then plus 37k. And you get plus 13k, which is 13k squared plus 13k. Subtract, and you get 24k. Plus 24, so you have plus 24, and that's 24k plus 24, which is 0. So we can say that this is 1/6 k plus 1, and then we'll have 2k squared plus 13k plus 24. Now, we want to show that this is equal to that. So what we can do is, I don't know if you can just expand that and say that it's the same thing. If I want to change this to k plus 1 all squared, then that will be 2k squared plus what is it? 4k and then plus 2. So I've just got a minus 4k plus 2. Minus 4k minus 2. And then plus 13k plus 24, which is equal to 2k plus 1 squared, and then plus 9k, and then minus plus 22. And then I can do the same for that. So I can say that that's 1 over 6, k plus 1, 2k plus 1 squared, plus 9k plus 1. And that will be 9k plus 9. So I need to minus 9 plus 22, which is 1 over 6, k plus 1, 2k plus 1 squared, plus 9k plus 1, plus 13. Is that right? Okay. Done. That was... It depends. Like if they'll accept if you just expand that and let them be equal, then that's not that bad. But if you had to get that yourself, it's a bit tricky. Consider the function with that rule. Consider z1 is equal to 1 plus 2i. Plot and label z1 and the conjugate. So 1 plus 2i will be here, and that's z1. And 1 minus 2i would be down here, and that's z2. Oh, sorry, z1 conjugate. Given that 1 plus 2i is a solution for f of z equals 0, find a quadratic factor. So conjugate root theorem, you can say 1 minus 2i is also a factor, given that all of the coefficients are real. Therefore, 1 plus 2i, 1 minus 2i is a factor, which is, 1 minus 2i is a solution. Therefore, z minus 1 minus 2i times z minus 1 plus 2i is a solution. And so if you expand this, you can do it as difference of perfect squares, like that. A squared minus b squared. And minus 2i squared will be plus 4. So this will be z squared minus 2z plus 1 plus 4. Hence, find all the remaining solutions of f of z equals 0. So z squared minus 2z plus 5 into z to the 4 plus 6z squared plus 25. That will be z squared on the top, z to the power of 4 minus 2z cubed plus 5z squared. Subtract and you get 2z cubed plus 6z here. So 2z cubed and then plus z squared. And then you'll say plus 2z, and then you have 2z cubed minus 4z squared, and then plus whatever, so subtract, you'll have 5z squared must have done something wrong. And then plus 25. You can say plus 5, and you have 5z squared. I will have a minus 10z plus 25. What have I done? Z squared. Did I write it correctly? Yes. That's minus z to the 4 minus 2z cubed plus 5z squared. You get 2z cubed plus z squared. And then you have plus 2z cubed minus 4. Whoops. Two z cubed minus 4z squared, and then minus plus 10z. And then you subtract and you get 5z squared minus 10z. And then the number's 5 and you get 5z squared and then plus 25. 5z squared minus 10z plus 25, which gives you 0. So z squared plus 2z plus 5 is a factor. And you can solve that equals 0. And you can use the quadratic formula, negative 2 plus or minus square root of 4. What have I done this time? Oh, they're all complex. Negative 2 plus or minus 4 minus 20. Over 2, which is negative 2 plus or minus 4i over 2, which is negative 1 plus or minus 2i. Show that f of x can be written in that form. So again, long division. All right, this says negative x squared plus 1. That's like 3 long division questions in a row. Or I just did it that way. So negative x squared, negative x. That gives you negative, what have I done? Yeah, x cubed divided by an x. So that's negative x. So that gives you x cubed minus x, subtract, and you get x squared minus 2x plus x is minus x. And then so you say minus minus 1. And you get negative x squared negative x squared minus 1, subtract, and you have negative x plus 1, or 1 minus x. Negative x minus 1 plus, it should just be 1. Negative x gives you negative x cubed minus 1 minus x. And then subtract and you get x squared negative 2x plus x is negative x. and then multiply, and you get negative x squared minus 1. Why is my remainder? Oh. Oh, that's fine. My remainder. Okay, yeah, so I think that's fine. I haven't done anything wrong. So it's going to be negative x minus 1. And then plus this negative x plus 1 over, plus negative x plus 1 over 1 minus x squared, which is equal to negative x minus 1 plus, and then you've got negative x plus 1 over 1 plus x, 1 minus x. And that cancels if x is an element of all real values except, well, of course it's not. We don't need to say that. So that's negative x minus 1 plus 1 over x plus 1. Okay. Consider the function with that rule. Find the value of k such that the graph is continuous at x equals 1. So we know that now it's this. It's the same thing. So we can say negative 1, the limit, we just need to find it. We don't need to show anything. So it should be negative 1 minus 1 is negative 2 plus 1 over 1. 1 over 2. And so negative 2 plus a half is negative 4 over 2 plus a half, which is negative 3 over 2. Sketch the graph. So negative x minus 1 plus 1 over x plus 1. So we have an asymptote at y equals negative x minus 1. That's the functional asymptote. And that has an x-intercept at at negative 1. And then we've got another asymptote at x equals negative 1, so label that. That's x equals negative 1. And then we've actually got an open circle at the, we want to sketch f of x, not g of x. So we're not filling in the negative 3 over 2. There's an open circle at negative 1, which is at negative 3 over 2. Sorry, at 1 or negative 1? At 1. So 1, which was at 3 over 2. Negative 3 over 2. So 1 and then negative 1.5. So it should be, where are the branches? It's going to be that, and then usually it would be like that and that. However, we're adding that to this line. So it should be above. And then this one will be like that. But remember that at 1, which is this negative 1.5, there's an open circle. Which is 1, 3 over 2, negative. Okay, I think that's all. That was an alright exam. It was a little bit tricky, some tricky questions, and it was a bit long, so hopefully everyone went well.